Hey everyone, I hope you're doing well today. In this video, let's do some practice with some absolute value. We'll start with that, and then some ordering and comparing rational numbers with absolute values, rational numbers meaning like fractions and decimals as well. Then we'll talk about the coordinate plane, plotting some points on the xy axis in the different quadrants, and then we'll also go into measuring distance on a coordinate plane. All right, so go through a bunch of different practice problems and see how we do. So let's start off with this first problem. Let's do something like the absolute value of 7, okay? So the absolute value of 7 is a distance from 0, so that's just going to be 7 units, okay? For a second example here, let's try finding the absolute value of negative 5.5. Well, that's just to the left of 0, but it's also going to be positive, and that's 5.5 units away from 0, okay? For a third problem here, let's go ahead and see. Let's find the absolute value of negative 19.5. That's also to the left, but it's going to be 19.5 units away from 0. That's all, right? We're measuring how far it is from 0. For the next one, let's try another decimal. Let's do absolute value of negative 102.06. Say, well, how far is that from 0? Well, that's going to be 102.06 units away from 0 in the negative direction, okay? Another example here, let's do the absolute value of 45. So how far is the number 45 from 0? That's to the right, and it's 45 units. Okay, nice and straightforward for these ones. For a sixth example here, let's try finding the absolute value of 48. The absolute value of 48, that's just 48. So go ahead and write that. That's also in the positive direction. Let's do a seventh example here. For this one, let's go ahead and do the absolute value of 21 1/3. Again, same idea, it's just a fraction, so if this kind of makes you feel uncomfortable because it's a fraction, don't worry, it's the same thing, so it's 21 1/3 units to the right of 0. Then for an eighth example, let's try doing the absolute value of negative 9. So this is 9 units to the left of 0, but the absolute value is going to be 9 units. That's how far it is from 0. Okay, so there's some problems just with some general absolute value, and now let's see if we can compare and order some. So let's say we're given some absolute value, so let's do the absolute value of 1/4. We're also given the absolute value of negative 1/3, and then we're given the absolute value of negative 1/8, and then let's do the absolute value of 0. And so the question is, let's order these values. Okay, so let's see what each of these are equal to. So for this one, the absolute value of 1/4, we know that's just 1/4. The absolute value of negative 1/3, that's just positive 1/3. The absolute value of negative 1/8, that's going to be positive 1/8. And the absolute value of 0 is going to be 0. So if we're going to try to put these in order from least to greatest, then we know that maybe 0 is the smallest. And then we also know that 1/8 is going to be it's a little bit bigger, right? And then 1/4 is going to be bigger. Oops, let's go ahead and put the less than symbol. It's less than 1/4, and that's going to be less than 1/3. So 1/3 is the biggest value here. Okay, so that's ordering them once we found out their values, but going back and writing the originals, we should say the absolute value of 0 is the smallest, and then the absolute value of negative 1/8 is a little bigger, and then the absolute value of positive 1/4 is bigger, and we're saying that the absolute value of negative 1/3 is the biggest value here. Okay, so that's us ordering them from least to greatest, ordering the original values, which were in absolute values. Okay, so it's important to know what they are equal to first. For a 10th example, let's try doing another ordering one. So let's have the absolute value of 6, and let's compare that with the absolute value of 0. And let's compare that with the absolute value of negative 9 and the absolute value of negative 4.2. Okay, so let's see here. The absolute value of 6, that's just 6. The absolute value of 0, that's 0. The absolute value of negative 9 is equal to 9. The absolute value of negative 4.2 is equal to positive 4.2. So if we're going to order these from least to greatest, then we hopefully know that 0 is the smallest, then 4.2, then 6, then 9. But if we're actually ordering, the original things we were given, we should write 0 came from the absolute value of 0, The 4.2 came from the absolute value of negative 4.2. The 6 came from, where did that come from? The absolute value of positive 6. And where did 9 come from? The absolute value of negative 9. So that right there would be the order of the original values given. Okay? So that's number 10. Let's see. I think we can go up and try maybe 11 up here. Number 11. Let's think of a situation here. So let's say we have 3 people with their accounts. So this first one's going to be Luis and Luis's account. Let's say we also have another person, Franklin. Let's say a third person here is going to be Hannah. Okay, so let's say Luis has a bank account, and on day 1, it's a certain amount, and then on day 2, it goes down. So the change between day 1 and day 2 is going to be negative $56.84. So again, we don't know what her account was on day 1 and day 2, but I'm telling you that the account balance went down by $56.84. In that same day, let's say that Franklin's bank account went up. So maybe he deposited money in, and money went in, so it's going to go up. So it's going to go up by $28.69. And let's say that Hannah's account is going to go up by $89.12. So again, this is going to be the change from day 1 to day 2. So imagine there's a bank account, and Luis's went down, but Franklin's and Hannah's went up. So the question I'm asking here is, or we're going to practice is, okay, so we don't know how much money is in any of their accounts. They could all have millions of dollars, or they could all have, negative amounts of money or very little bit amounts of money, but this is the amount of change on each of their days. So Franklin's went up, Hannah's went up, Luis went down. So the question we're going to try to do here is, let's put the amount of change from least to greatest. Well, who's changed the least amount? Well, the least amount was going to be Franklin. Okay, so Franklin changed the least amount, right? Only changed by $28 And then who changed more? Well, Luis changed more after that, right? Luis changed by about $56, and then Hannah changed by $89. So it doesn't matter what the values were, it matters how much was changed between each of these. So I'm actually going to go and make sure we have all the answers kind of easy to read. So let's go back to number 9, and let me box that one so that's easy to read, so you can see where the answers are. 10, this is them comparing their values. And then for number 11, these are the people in order from the least change to the most change. Okay, it's not the least amount in the bank or anything. We don't know that. We just are talking about how much it's changing by. Okay. Okay. Let's try another example where we're comparing change and trying to understand their absolute values. Okay, so trying to find their absolute values. So even kind of going back to 11, just to re-look at this, if you take the absolute value, you can see the amount it changed was $56.84. If you see the amount this one changed, that one would be $28.69. And if you see the amount changed, so again, it's just distance from 0 or absolute value, right? So if that helps then compare those numbers instead, that lets you know how much change there was going on. Okay. All right, let's check out another one here. Let's say we have some people with their test scores. We have, let's say, 5 students. So let's do Antoine, and then we'll do Lauren. Okay, and then we'll do Micah. We'll do Beth. And then we'll do Pat. Okay, so let's say these 5 students all take a test on a first day, and they answer a certain amount of questions right, and then they take another math test or a test, doesn't matter what class it's for, and they get another score. So it turns out between the first test and the second test, Antoine did better on the second test. So he did 4 questions better on the second test. Let's say Lauren, from the first test to the second test, on the second test she actually did worse by 6 questions. For Micah, let's say Micah did better on the second test by 3 questions. Let's say Beth actually did the same on the first test and the second test, so her change was 0. And let's say Pat did worse on the second test by 5 questions. So looking at all these numbers here, we can try to see maybe who changed the most, right? If you want to figure out how much they changed, well, Micah changed by 4, right? But Micah did better, or sorry, Antoine changed by 4, but he did better. Lauren changed by how much? Well, she changed by 6, but in a poor direction. She did worse on the second test. Micah did a change of 3, but that was in a good direction. Beth changed by 0. She did consistently the same on both. And then Pat did 5 worse on the second test, but his change was 5. So if you're comparing their changes, you'd have to compare them in order. Least amount of change, a little more change, a little more change, a little more change. Lauren changed the most in a bad direction, but Antoine changed the most in a good direction. But if we're just talking about change, we don't care about the direction. We're just talking about how much. So I guess a question we could ask here is it possible that Lauren answered more questions correctly on the second math test than Lauren did? Sure, right? So like just say there was a 50 question test, right? Again, we don't know how many questions are on there, but let's say there's 50 questions. Is it possible that Lauren maybe got an 87 questions? Sorry, I just said there are 50 questions. Let's say Lauren got 40 questions right on the first test, and if she did 6 worse on the second test, right? If she did 6 worse, that means she only got 36 questions right on the second test, right? But if we're going to maybe compare Lauren to Antoine, right? So if we compare her to Antoine, even though Antoine did better on the second test, is it possible that Antoine maybe only got 20 questions right on the first test, but he did 4 better on the second one, right? He did 4 better on the second test. So is it possible Antoine got a 24 on the second one? Sure, that's possible. We just need to see that the change was correct. Antoine did better, Lauren did worse. I mean, is it also maybe possible that Lauren did worse and maybe Lauren got 15 questions right on the first one and then did worse and only got 9 questions right because she did 6 questions worse, and maybe Antoine got 45 questions right on the first one and then he improved by 4 and got 49. So do we know what their scores were? No, but it's possible that Lauren did worse than Antoine on both, and it's possible either one did better on the first and second. It's possible they kind of passed each other too. So the question to kind of look at this whole scenario is looking at how much each of them changed by, but we don't know their actual scores. That information is not given here. So we don't know that information, and they could have done better or worse, and it's possible. Okay, so that's this question here. Let's try another application here comparing some integers. So let's try a 13th example. Let's say that there is a bird that's flying and then there's a fish that's swimming, and we want to compare these two items here. So I'm going to say that a bird, where would a bird fly? Is that positive or negative? The bird would be positive 13 7/10 if it's flying in the air. And let's say we have a fish, and this fish is going to be located underwater, right? So I'd hope so. Negative 16 1/5 would be its location. And let's say, which one is farther from sea level? Well, we can go ahead, if you want to, and just kind of draw the ocean here. That would be sea level. That would be, say, 0 feet. And where would the bird be? The bird would be somewhere up here. And what's that distance? That distance would be from here to here would be 13 7/10. That's in the positive direction. And let's say we have a fish, and this fish is going to be, I don't know, I can't really draw a fish, but let's say that fish is down here, or I'll draw it next to it. That fish is right over here, and that's going to be negative 16 1/5. So if I said, hey, well, which one is further from the ocean, like the sea level, then we can kind of compare these two. We can compare their absolute values, and hopefully it makes sense. If you look at their absolute values, we know which one's further, but this fish is going to be further. The fish is farther. I know it's a negative number, but again, its distance is farther from sea level than the bird is. Cool. That would be the answer for this one. Okay. Let's see. Let's do a little bit more comparing here. So that was comparing maybe a positive and a negative number. let's maybe look at some temperatures now. That's a pretty common application here. So for a 14th example, or a practice problem here, let's consider some temperatures in some different locations or in different days of the week. So let's say we have a Monday, okay, and we'll have Tuesday, we'll have Wednesday, and let's do Thursday. Okay, so let's say on Monday, we know the temperature is going to be 3 degrees Fahrenheit. Let's say on Tuesday, we know it's going to be -4 degrees Fahrenheit. On Wednesday, it's going to be -1 degrees Fahrenheit. And on Thursday, it's going to be 2 degrees Fahrenheit. Okay, so again, if you don't see a plus sign, it's positive. If you do see the negative sign or the minus sign, it's the opposite or the negative. So let's see if we can find each of their absolute values to see like which one is furthest from 0 degrees. Okay, just practice comparing here. So this one's above 0, so the absolute value is just going to be 3. How far away is this from 0? That's just going to be 4 degrees away. This one is only 1 degree away, and this one is 2 degrees away. Okay, so these are all of the distances of each of these temperatures from 0. In terms of the coldest day, well, we need to see which one was furthest from 0 in the negative direction, right? So in terms of that, we can maybe say that this would be the coldest. Okay. It happens to have the greatest absolute value that was below 0, where it actually was below 0, but its absolute value was furthest, so it was the coldest temperature here. Okay, so there's a bit of practice on just looking at absolute values and comparing them and trying to understand the differences between different distances from 0 and absolute values. All right, so for a 15th example, let's look at the coordinate plane and just practice plotting points here. So let's see for B, if we want to find out where B is, we start at the origin, then we move 2 units to the right, that's +2, and we're going to move 2 units up, which is also +2. So we go to the right first, and then we go up. Okay, so that's where letter B would be located. That's its ordered pairs, okay? Or its ordered pair, rather. For a 16th example, let's try plotting D, or not plotting D, but saying it's ordered pair. So where's D? It looks like D is down here. So we would have to go to the right, it looks like it's 8 units, that's +8, and then we're going to go down here 8 units. Okay, so that's going to be a +8 and then a -8. It's 8 to the right and then 8 down. Here we have question 17. Let's see if we can plot where F is. So for F, that's located up here in quadrant 1. Let's go, how many units is that? 1, 2, 3, 4, 5. Looks like 6 units to the right, and then we're going to go 6 units up here. Okay, so we're going to say for F, that's going to be 6 units to the right, and then 6 units up. That's going to be 6, 6. Okay, let's try another one. Let's see if we can plot where H is. So for H, where is that located? Looks like down here in quadrant 4. To get to H, looks like we have to go 1, 2, 3, 4 to the right, and then 1, 2, 3, 4 down. So 4 to the right for H is going to be +4, and then down 4 is going to be -4. Okay. For 19, let's go ahead and try doing J. So for J here, that's located right here on the y-axis. So we're actually not going to move left or right. So we know we have to put a 0 first. We're not moving left or right. And then we have to move up. I think it's up 4 units. So that's +4. Okay, so there are 5 examples right there on writing ordered pairs. These are ordered pairs because they're in order, x first, y second. And they're pairs because there's 2 numbers. Okay, let's try another one. But this time, let's go ahead and see for question 20. I'm going to put a dot on here, and you can see if you can identify where it's going to be. So I'm going to say, let's say we have V, letter V, and it's going to be located at -9, 3. And I say, hey, go ahead and plot this. Okay, so I'm going to use a different color to show this. So for V, maybe I'll change this to green here. How does that work? We have to go 9 to the left. That's going to be 9 to the left because it's -9. And then we're going to go up 3. Right, so there's the -9, and there's the +3. So we're going to go ahead and put V right over here. There's V. That's how you plot that 1 point. Okay, that's question 20. Let's try 21. Let's do another letter here. Let's try X. So let's say plot point X, and that's going to be located at 8, 3. That's over in quadrant 1. So you start at the origin. This positive 8 means let's move 8 to the right. That's positive 8. And then this 3 here means we're going to move up 3 units. That's going to be positive 3. So that's where we're going to plot our point X right over here. There's X. Okay, there you go. Let's try maybe one more, practicing, just making sure we feel really good about this. Okay, hopefully our confidence is building a bit here. And let's do point Z. Let's go ahead and try to plot point Z, and that's going to be located at -5, 0. If it has a 0 in it, it means it's not in a quadrant. So let's see. -5 means we start at the origin and move 5 units to the left, right? And the 0 here means don't go anywhere, just stay right there. Okay, so I'm going to go ahead and plot that right here, and that's going to be where Z is. Okay, so going ahead and examples for 20 to 22, just kind of plotting some points. Okay. So for in this coordinate plane, notice how all the boxes are worth 1. So I can write these in the middle if it's helping to make it clear. And for this next set of questions, let's try mixing it up a little bit and saying that the boxes are not worth 1. Okay, so for these next few practice problems, let's try to pay real close attention to what's going on here. You want to pay attention to the spacing that we see on the axes. So notice how 1's actually here and 2's over here. -1, -2, +1, +2, -1, -2. So every box actually isn't worth 1 unit here. So we have to do a little bit of thinking. So we see that there's actually 1, 2, 3. There's 3 lines in between, which means that each of these, there's 1, 2, 3. There's 4 units in between. That must mean that this is 1/4, 2/4, 3/4, and 4/4. Each of these boxes is really worth 1/4 of a unit, or 0.25 as a decimal, right? So for 23 here, let's see if we can find out where this point B is located. So I'll put point B right over here. Let's see if we can identify where that's going to be. So for point B, that's located right over here. We're going to go 1/4, 2/4, 3/4, 4/4, which is 1, and another fourth, that's going to be 5/4, or also known as 1 and 1/4 to the right. Once we go over 1 and 1/4 to the right, we're going to go up 1/4 and up another fourth. That's 2/4, but remember 2/4 is the same thing as 1/2. So point B, that's where it would be located. Okay, let's try another one. For 24, let's try finding D. Okay, so for point D, let's see if we can locate that. D is located right up here. So let's first start the origin, and let's see, do we move left or right? I don't think so. It's going to be 0 units left or right. And then we're going to go up 1/4, 2/4, 3/4, 4/4, or 1, 1 and 1/4, 1 and 2/4, also known as 1 and 1/2. That's where D would be located. For 25, let's go ahead and see where F is located. So for F, let's go ahead and see F is located down here in quadrant 4. So let's see, that's going to be 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. 6/4 is also known as 1 1/2. It's right between 1 and 2, and that's positive. So after we start at the origin, we go 1 1/2 this way. Then we have to go 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. And keep in mind, 7/4 is the same thing as 1 and 3/4 as a mixed number. So that one is going to be negative though, because we're going down. Okay, so for B, B is in quadrant 1. It makes sense it's positive, positive. D is on the y-axis, so it makes sense that there's a 0 located in it. And F is located in quadrant 4, so you go to the right, then you go down. Okay, let's try another one. For 26, let's try H, figuring out where H is located. H is going to be, let's see, we start the origin, move 1, 2, 3, 4, 5/4 to the left. So that's -5/4 or -1 and 1/4. And we don't go up or down, so it's going to be 0. It's located on the x-axis. Okay. For 27 here, let's go ahead and try to find where J is. So let's see, where's J? J is over here in quadrant 3, so it should be negative, negative. So we start at the origin, that's 1/4 to the left and 1/4 down. So 1/4 to the left means negative, and 1/4 down is also negative. So there are 5 points there, but using fractions instead. So just keep in mind, you have to look at the scaling of the x and y axis. Each box is not worth 1, it's worth a quarter each of the ways. Okay, so now that we've looked at them and tried to write down their ordered pairs, let's try doing the opposite here. So for example, or problem 28 here, I'm going to say, what if we give you v? I say v is at -1/2, comma, +1. I say, hey, go ahead and plot that thing. Okay, so start at the origin. -1/2 means you're going 2 to the left. That's 1/4 and 2/4. That's -2/4 or -1/2. And you have to go up 1, 2, 3, 4/4, or that's the same thing as +1. So right over here, we can plot the point V. Okay. For 29, let's try plotting another point. Let's do X. And for this one, let's say that's going to be at 1.75, comma, -0.75. So that should be in quadrant 4 because it's positive, negative. But let's see here. This is 1.75, also known as 1 3/4. So that's going to be 1 3/4. That's all the way right here, close to 2, but not quite. And then down 0.75, which is down 3/4. So this is, again, plus 1.75 to the right. And then this is going to be down 0.75, or the same thing as 3/4. So this is 1 3/4, and this is -3/4. Okay, so I'm going to go ahead and plot that right down here. I think it's going to be just about right. That's going to be X. Okay, so there you go. That is where X would be located. Let's try just a couple more. Let's do one more here. I'll do question 30. Let's go ahead and do Z. And we'll say Z is located here at 3/4, comma 1. Okay, so back to fractions here. So 3/4, we're going to start at the origin, and 3/4 is going to go 3 of these boxes to the right. That's 3 out of 4. And then we're going to go up +1. So that's +3/4, and this is +1. And we're going to go ahead and put a point right here. That's where Z will be located. Okay, so far, hopefully this is getting a little bit better, but I know the fractions can be a little bit frustrating. Just try to hang with it and look at the scaling so that it helps you make a little bit more sense of what's going on. Okay, let's try some more in just a bit. All right, so let's take a look at a 31st example here. But let's try to make sure we understand what's going on. So I have, how many points here? We have 1, 2, 3, 4, 5, 6. So 6 different locations on this coordinate plane. And let's look at the scaling of it as well. So notice how this is +1, +1, -1, and -1. So that makes things pretty interesting here, because that means you have to see what the boxes are actually worth. So just so you know, we have 10 boxes in every direction. So if we split this whole length of 1 into 10 equal pieces, this would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10, which is the same thing as 1 whole. Okay, so keep that in mind, that every box is worth 1/10, and you can either think about that 1/10 as a fraction, or you can think about it as a decimal of 0.1. But either way, each box is worth 0.1 or 1/10 here, same thing. Okay, so for question 31, I'm going to say, let's try to locate then what is at what is that? Located at -1/2, comma 2/5. Okay, let's see if we can do this together. So where's -1/2? Well, this means we're moving to the left. So what's half of 1? So that's going to be 1/10, 2/10, 3/10, 4/10, 5/10. So again, that's -1/2 because this is a whole. So that's going to be halfway to that point. And let's think about this. So this is -5/10, right? So -1/2 is the same thing as -5/10. And for 2/5, if we multiply by 2 on top and bottom, that would be +4/10, right? So this is another way to think about it. It's -0.5 and +0.4. So if you want to think about it as a fraction or as a decimal, either one's okay. And then so we also have to move up 4/10 now, or 4 boxes. There's 1/10, 2/10, 3/10, and 4/10. So we're saying, where is this located, or what point are we talking about? This is going to be point B here. So let me just go ahead and make that one the same color so it's more standing out a little bit more. So whatever would be located there would be point B. That's at -1/2, comma, +2/5. Okay. Let's try one more question dealing with this. And let's say, suppose maybe there's some treasure marked right, I'll put it right here. So I'm going to say this is where some treasure is located. That's the origin, right? Some treasure pointed right over there. And let's say that you are looking for this treasure and you are located at, I'll make this a different color. I'll make this point C. Let's say you are at point C and you want to get to this treasure. And I ask you, okay, you have to stay on the grid lines, okay? And you have to find the shortest route to getting to the treasure. So let's see. If you're trying to get from point C to the treasure, let's see where point C is located. Point C is located at, I use this, point C, it's in quadrant 3, so it's negative, negative. It's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. So it's -7/10. Okay, it's to the left. And after we go 7/10 to the left, it's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, -6/10 down. I know I can simplify that to 3/5, but I'll just write it just so, if that helps, you can see. And so it's -3/5. Hopefully that makes sense. Again, every box is worth a tenth. And we're trying to get to this location of the treasure. Okay, so what's one way that we can take to get from C to the treasure? So C, and we're trying to get to the treasure. I'll just put T for treasure here. Okay, well, one way we could go is we could go up first, and then we could go to the right. That's one way to do that. So if this first scenario, let's say scenario number 1 here, we could go up how many units? That would be up 7/10 units. Okay, so that would be going up 7 boxes or 7/10, and then we could be going to the right how many? Did I do that right? It's going up, no, 1, 2, 3, 4, 5, 6. Sorry, it's up 6/10 units. Up 6/10. Or you can write 3/5, right? Up 6/10 units. Sorry about that. 1, 2, 3, 4, 5, 6. And then we're going to go to the right 7 units. So we're going to say we're going to go to the right 7/10 units, or 7 boxes is really what's happening. So that's one way we could do it, right? Another way we could do it is we could start at point C again, but let's go to the right first, and then let's move up. So if we did this second method here, then first thing we would do is we would move to the right 7/10 units, and then we would move up 6/10 units. So just keep in mind here that there's 2 ways of getting there, right? We can get the same location. So if we can only go on the grid lines, we can go up, then we can go right, or we can go right and then go up. But either way, you end up at the same destination and you get your treasure, which is great. All right, let's move on. Let's try another one. All right, so for question 33, let's try plotting some different points on this coordinate plane here, but notice how we have different scaling again. So we're going to try plotting this first point E, and E is going to be located at -2 1/4, comma, -1 3/4. So let's see if we can go ahead and do that first. We'll do a few different points, but we'll start with this E. So this is -2 1/4, so we start at the origin. And it looks like every box is worth 1/4 here, so that's -1, that's -2, and then one more box would be -2 1/4, so that would be located right here in the left direction. And then we have a -1 3/4, so we have to go down to -1, which is here, and then -1 1/4, -1 2/4, and -1 3/4. So I believe our dot would be right here. So -2 1/4. Let me just check that again. That's -2 1/4, I believe that's right. And then down -1 3/4. So here's -2, so it's only 1/4 away. So I think that makes sense. Okay, let's try another one. Kind of just getting used to these fractions and decimals. So let's do +1.5, comma, -2.75. Okay, So let's go ahead and see if we can try that. So for this first value, it's positive. So 1.5 is going to be 1.5. That's right here. And then we're going to go down. We're going to go down 1, go down 2.75. It's almost at -3, but not quite, right? So this right here should be F. Just double checking, is this at -1.5? Yep, that's 1.5. And then double checking this way, that's -2.75. That works. Okay, let's try another one here. Let's try G. For G, let's do -0.75 and then comma 0. And let's see if we can figure out where that is going to be. So -0.75, that's -3/4. So start at the origin, 1/4, 2/4, 3/4, that's right here. And then let's not go anywhere else. So we're going to stop. That one's nice, a little bit easier to do maybe. And that's going to be G. Okay. Let's do maybe one more here. Do H. Let's say H is located at +3, 1.5. So it's positive, positive. That should be in quadrant 1. So start at the origin, 1, 2, 3 units this way, and then up to 1.5. So here's 1, and then 2 more boxes gets us half. So that would be right here. So I think it's right over here. I'm going to just double check this. So if I go down on the X value, that is 3. If I go to the left to get the Y value, that's 1.5, and that's 1.5. So good. I think that is true and correct. All right, so at this point, we've done quite a bit of coordinate plane work. We're going to actually go now back to seeing if we can now find distance, not go back, but find distance. And let's do distance on a coordinate plane. So that was 33. Let's try example 34 here. For example 34, let's start talking about like finding the distance between points on a coordinate plane. So let's say for 34, we have the point -6, -4.7. So hopefully you know that's going to be in quadrant 4. And I'm going to say, hey, let's find how far that is from something else, right? So if you've ever looked on a GPS, it'll tell you like how far away you are, and you have to drive on the roads. And you are going to see how far these two are from each other. So how do you show that, especially using absolute values? Well, first you want to identify if you have two matching numbers, that's a good thing. Then you take a look at their non-matching numbers or non-matching numbers here. So you then look at their non-matching numbers and you decide, okay, are they the same sign or are they different signs? If they're different, we're going to add their absolute value. So here we're going to take the absolute value and we're going to add the absolute value of the other one. So we have this -4.7 and we're going to add the absolute value of 4.1. So again, it's their non-matching numbers there. Maybe I'll use these same colors that I underlined and maybe that makes more sense. So I'll do that. Okay. Again, if they're in different quadrants, you're going to add their absolute values here. So what's the absolute value of -4.7? That's just 4.7. And what's the absolute value of 4.1? That's just 4.1. So what's the total distance here? It's going to be 8.8 units. Okay. That's how far these two points would be from each other. Okay, so that's 34. Let's try 35. Another distance one. So let's say we have two more points. Let's do -7, -4. That's located in quadrant 3 because it's negative. And let's see how far apart that is from -7, 9, which is in quadrant 2, right? So let's see, do we have any matchy numbers? So another matchy with a matchy, that's good. That means finding distance is going to be easy. And so we have to find out how far apart these numbers are from each other. Okay, so again, they're different signs. One's in quadrant 3, one's in quadrant 2. So we're going to add their absolute values again. So go ahead and set those up. We'll see how far is -4 from +9. The absolute value of -4 is +4, and the absolute value of this +9 is just going to be +9. And 4 plus 9 is going to be 13, so it's going to be 13 units. So right there is going to be our distance between these 2 points. And if you want to plot them, go right ahead. But I promise you that is how far they are from each other. Okay, let's try 36. 36, let's go ahead and try, okay, let's see, we have the point 7.5, -6. And say, okay, how far is that from this 7.5 comma, negative 2.5. Okay, well, let's see, are there any matching numbers? So here, this one matches this one, so that's good. This is going to be not too bad. And then we can go ahead and find the distance between these 2 points. All right, so let's see, are they the same or are they different? I think they're in the same quadrant this time, right? They're both negative. So we're actually going to subtract their absolute values instead of adding. Okay, so we'll put the further one first and the closer one second. And so the absolute value of negative 6 is 6. And the absolute value of negative 2.5 is just going to be 2.5. And so what is 6 minus 2.5? Well, it's just going to be 3.5, but I'll kind of go through maybe how we've learned it in pre-algebra for subtracting fractions. So 6 is the same thing as 6 over 1 as an improper. And 2.5, if you convert that to an improper fraction, that would be 2 times 2 is 4, plus 1 is 5, so it's 5 over 2. Then you need common denominator, so times 2 times 2. So this would be the same thing as 12 over 2 minus this 5 over 2. And 12 over 2 minus 5 over 2, that's going to equal 7 over 2. And as a mixed number, that's going to be 3.5 or 3.5. 3.5, I forgot the U, in units. So, however, if you can do it in your head, great. Or if you want to do it, just by writing this out and how to get the exact value, hopefully that work helps you out a little bit. Okay, so these 2 points are 3.5 or 3.5 units away from each other. Let's try 37. Let's try another distance problem here. And let's do 2 points. We'll do negative 3 comma 8.5. Let's find the distance between that and let's do negative 3 comma 7.7. Okay, so let's try to find the distance between these. Well, we should like that these two are both negative 3. That means we can find the distance. And let's see how far apart these are. Notice how they're the same sign. They're both positive, so we can actually subtract their absolute values. So the further one's 8.5, the closer one is 7.7. The absolute value of 8.5 is 8.5, and the absolute value of 7.7 is going to be 7.7. So what is 8.5 minus 7.7? I'll write it on the side here, even though if you have a calculator, you'll probably use that, or you can do it in your head. We can borrow, make that a 15. That's going to be an 8, so it's 0.8. So 0.8 units away from each other. Okay, these points are pretty close. All right, so that's finding some distance. And now let's look on a coordinate plane for these next few. All right, so for question 38, or practice problem 38 here, let's see if we can find the distance of some items here. So let's see if we can find the distance between, let's do point A and find the distance between this point A here, and let's do with C. So point A to point C, let's see if we can find their distance. So let's see what A's coordinates are. A is located at this point here, so that's how many units? That's 1.5 to the right and 3 up. So that's 1.5 to the right. Whoops, I'm just gonna go ahead and use black here. 1.5 to the right and then 3 up. And let's see where C is located. C is located over here, so that's gonna be 2.5 units to the left and then 3 units up. So 2.5 left, that's negative 2.5, and 3 units up. And we're finding the distance between these. So let's see, their matching numbers here are 3, and so their non-matching numbers here are 1.5 and negative 2.5. If they're different signs, we're gonna go ahead and add their absolute value. So positive 1.5 and negative 2.5. That's gonna be 1.5, that's gonna be positive 2.5. Adding these should be 4 units apart. Okay, so that's the algebra behind it. Obviously, if you look at the graph, you can maybe see if that makes sense as well. I'm gonna go ahead and see if I can show that. So remember, every box here is worth half. So this is really 1 unit. 2 boxes, that's another 1 unit. 2 boxes, that's another 1 unit. And then 2 boxes, another 1 unit here. So that's 4 total units across, and that verifies that these are 4 units apart. Okay, that's 38. Let's try I don't know, let's try another one here. Let's try 39 and give it a go. So for 39, let's see if we can find, what if we reflect some points? So let's take point D. Let's take point D, and we're going to reflect it across both of the axes. So let's see. If I reflect it, it doesn't matter which one you do first. This should be okay either way. Let's see if we reflect it across. Let's go ahead and write this down. Use purple here. Reflect. Oops. Reflect. There's an L in there. Reflect across the x-axis. So what does that mean if you're reflecting? Well, imagine the x-axis is right here, and we're going to literally reflect it. So if D is standing and facing this mirror here, how far away is D from this? Well, you can see that it's 1, 2, 3, 4, 5 units away from it, okay? Or 5 boxes. I know it's not really 5 units, it's really 2.5, okay? And you can see that because that's this distance here, 2.5. So if it's 5 boxes away and you want to reflect it, then you're going to go 5 boxes on the other side. Okay, so if you see here that this is 5 units away from the x-axis and we're reflecting across the x-axis, then you need to go 5 of these boxes on the other side. Okay, so what we call this, if we reflect it, we call that D with a little line. That would be a prime, so that's the reflection of it. Okay, so what are D's coordinates anyway? D's coordinates are located at -4, -2.5. That's where D's located. If you reflect it across the x-axis, that D with a little line, D prime, that's going to be still at -4, but now its y coordinate is going to be +2.5. So notice that we start here, and it's going 2.5 units up, or 5 boxes. And so if you reflect it, it's going to be up here, which is going to be 2.5 units, or 5 boxes above. Okay, that's that reflection. Now, let's say we want to do another reflection. Like, let's say we want to reflect this across the y-axis. So let's say reflect this across the y-axis. Okay, so where's the y-axis? Well, the y-axis is right over here, and we want to reflect it across it. So how far away is this from the y-axis? Well, you can see it's 4 units to the left of it. So if you reflect it, it's got to be 4 units to the right of it. We're going to call this D double prime. Okay, so again, how do you figure out that reflection? Well, it's 4 units away this, and so it's going to be 4 more units on the other side. So if you want to reflect this, you can say, okay, well, D double prime started at, D prime is starting at -4, 2.5. And if we reflect it, then it'll be located at 4, 2.5, or +4, right? So if this was at -4 to the left, it's now at +4 to the right. So you're going to notice something here, actually, that when you reflect it across the y-axis, these x's flip, and when you reflect it across the x-axis, the y values flip, and that's always going to be true. So the question was saying, what if you flip, or the question I'm asking you here is, or we're practicing, is what if we flip point D across both axes? Where is it end up being located? And so the final location here would be this 4, 2.5. And that's if we flipped, again, we flipped it across the x, then we flipped it across the y. It's also possible to flip it across the y first and then flip it across the x, but you're going to notice you end up in the same location either way. Okay, so a little bit more tricky problem, but when we talk about reflections, you're just comparing it to that axis. So when we compare it to the x-axis, this is the x-axis, 2.5 boxes, or 2.5 units, 2.5 units, okay? And we flip it across the y-axis, it's going to be 4 units this way, 4 units over here. That's the new location, okay? All right, let's move on to another question. All right, so here is question 40. And so for question 40, what we're going to do here is take a look at this coordinate plane. But notice how we're not really given too many bits of information. It's a little bit more of a puzzle since we don't necessarily know where all the things are, and we have some variables. So let's first take a look at this information that we do know. I'm telling you here that point W is located at n, 1. And you're like, maybe, I don't really know where n is. Well, notice how this V down here, point V, has an x-coordinate of n. So n is located right here on the x-axis. So if I were to draw kind of like a dotted line up here and say like, okay, this value then on the axis must be n, okay, because that's the x-coordinate of it. Now, what we also need to know is like, where is this w going to be then? Well, for w, that means we have to go n to the right. That's how many units to the right, because it has to match this one. And then it's going to be positive 1, so it has to go up 1 unit. So if I were to make a rough sketch, I think that w would be located right here. Okay, so again, this is n comma 1. So if v is n comma negative 5, then w has to be n comma positive 1. So it has to be in quadrant 1 there. Okay, so now that we know where w is, this should hopefully get a little bit easier. And so what are we being told? We're being told that the distance from v to w matches the distance from v to u. So where's v to w? So v to w, I think that's this length here. Whoops. Let me try to write that out here. That's this distance right here. They're saying that distance matches this distance. They must be equal in length. Okay, so that being said, let's see if we can find out what is the value of n. Okay, so that's kind of the question that we're going to see if we can figure out based on knowing that these two lengths are the same thing. Okay, so let's see if we can figure out some coordinates here. So for w, right, we know w is located at n comma 1. That's true. Okay, we're being told that. For v, we know that's going to be located at n comma negative 5. Okay, and the last one we don't really know is this one, right, is u. But isn't u located on the y-axis, right? Kind of messed that up. So if we're trying to get from the origin to u, we don't move left or right, we just move down. So for u, we move 0 units left or right, and how many units down do we move? Well, if u is next to v, how far down is v? V is 5 units down, so u must also be 5 units down. Okay, so let's see if we can figure this out a little bit more now. So again, w is n comma 1. That was given information, n comma 1. Then for v is going to be at n comma negative 5. That was also given. And u, we had to do a little bit of thinking here, but u's on the y-axis, so it doesn't move left or right, it just moves down, and it must be 5 units down because it's next to v. So let's go ahead and take a look at these two to find their distance, if it's possible. And so let's see. We look at their matchy-matchy numbers here. What do they match? It looks like, let me see if I use a different highlight. Just say, like, okay, this matches this. So you might remember from earlier, if those match, then you just see how far apart these are from each other, right? So you take the absolute value of each of these. They're different signs, so we'll do the farther one first and the closer one second. So it's going to be 5 minus 1. That's going to be, oh, actually, wait, sorry. They are opposite signs, so we're adding. So if I confused you for a hot second, then sorry. That's going to be 6 units apart. And hopefully that makes sense too. Let me show you on the graph what that looks like. So that would be 1 unit down. All right, this is 1 unit, and here are 5 units down. So that's a total of 6. Okay, so if that's true, then we should be able to say that these are also 6 units apart. All right, if those lengths are the same. So if we're now looking at these two are supposed to also be the same distance apart, then we should say, oh, okay, if we look at this n and 0 have to be 6 units apart from each other. So what number could n be here so that it's going to be 6 away from 0? Well, there's only 2 numbers in the world that are 6 away from 0. If we add 6, that's going to be a positive 6. And if we take away 6, that would be negative 6. So if we said n was negative 6, that doesn't quite make sense because take a look. We are in quadrant 4 right now. And in quadrant 4, you must have a positive and then a negative. So that's how we know we need to go with this positive 6 here. Okay, so what's the value of n? N is equal to positive 6. that would be the answer for question 40 here. All right, for question 41, let's try to imagine something here. Let's say we have this guy, Jorge, and Jorge is going to be standing at 11 comma negative 11. Okay, that's where Jorge is going to be. And let's say that he has a friend, Leslie, and Leslie is standing at 1 comma negative 11. All right, so that's where Leslie is standing. And so Jorge is going to walk 10 units to the right. So he's going to go ahead and walk. He's going to walk, I'll write it out, 10 units to the right. Okay. And I want to know, or let's see if we can figure out here, if he will be standing with Leslie. And the question is like yes or no, if he walks 10 units to the right. So let's see. If we try to think about this, how far apart are Jorge and Leslie from each other? Well, they have these matching numbers here. So the question is okay, how far apart are their other numbers, which is 11 and 1? They're both the same units, both positive, right? So we can subtract their absolute values. And so the absolute value of 11 is 11, and the absolute value of 1 is going to be 1. So they are indeed 10 units apart from each other. But we want to make sure we understand if Jorge walks to the right, if he's actually going to meet up with Leslie. So we need to know if Leslie's to Jorge's left or to Jorge's right. So you don't have to make a very detailed XY plane, but maybe this will help you see what I'm talking about or what the picture is imagining. So where's Jorge? Jorge is 11 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But he's also 11 units down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's say this is Jorge. I'll put a little J there for Jorge. And where's Leslie? Well, Leslie is going to be 1 comma negative 11. So that's 1 to the right and then 11 units down. So here's Leslie. I'll put a little L here. Okay, so they are indeed 10 units away from each other, right? This measurement here is 10. But here's the question. If Jorge walks 10 units to the right, then he's walking this way, right? He's walking 10 units over here. I'll write it, try to make it the same length-ish. So he's going plus 10 units. So if Jorge walks to the left, then he would end up next to Leslie. But if Jorge walks to the right, then he's not going to be. He's even going to be even farther away from Leslie. So the question here is, will he be standing next to Leslie? The answer here would be no. He will be 20 units away. 20 units away. If he went to the left, then he would be standing right with her. But if he went to the right, which is what happened, then he's even farther away. For question 42, let's just do 2 more problems here. For this next one, I'm going to say let's write 4 ordered pairs so that they're in different quadrants. So remember what the 4 quadrants are. We have quadrant 1, 2, 3, and 4. So it's 1, that's 2, that's 3, and then that's 4. So if we have to write 4 ordered pairs and they all have to be in different quadrants, keep in mind it's positive, positive here, it's negative, positive, it's negative, negative down here, and it's positive, negative in quadrant 4. So let me come up with 4 different ordered pairs here, and this can vary, everyone's could be different. So make up a positive, positive here. So I'm going to say 3 comma 2.5, that's positive, positive. That's for quadrant 1. For quadrant 2, let me make up one, has to be negative, positive. Let's do negative 1, positive 1. That's in quadrant 2. For something in quadrant 3, let's do like negative 3 comma negative 4.5. That's negative, negative. And then for quadrant 4, we have to have a positive. So I'll do 5 comma negative 0.2. That's a negative. So there's 4 points in each of the 4 quadrants. Okay. Let's move on to one last example. All right, so for this last example, let's go ahead and see if we can plot all of these points on this coordinate plane. Just practice plotting with fractions a little bit. And then after that, we'll go ahead and see if we can find a distance or see if we can find something specific about them. Okay, so for this first point, I'm gonna call this one, or I'm gonna make this green colored. Okay, so it's 4.5 comma 1. So notice how each of these boxes is worth 1. So we might have to go in between some boxes here. So 4.5, this is 4, this is 5, so 4.5 is located right here. And we have to go up 1 box. So 4.5 comma 1, that's going to be this dot right over here. Okay, and let's go another one. Let's do this negative 1 1/4 comma 2.5. So let's see, we have to go 1 1/4 to the left. So here's 1. 1.5 would be here, so 1 1/4 is a little bit closer, and then 2.5 has got to go up. So let's see here, negative 1 1/4, and then 2, that's 3.5. So I think it's right here. Let me see if I can confirm that. So this is negative 1, and then this is negative 1.5. So 1/4 should be here. That makes sense. Negative 1 1/4. And then here's 2, here's 3. So 3 and 2.5 should be right in between here. So I think this is good, right about there. Okay, it's got to be in between those boxes. For this next one, we have 2 1/4 comma 2.5. So 2 1/4, where's that? 2 1/4, so it's a little bit past 2, and then 2.5, so it's going to be 2.5, so it's going to be right above here. So 2 1/4, 2.5. Thinking it's right about there. So again, where's 2 1/4? Here's 3, here's 2.5, 2 1/4 is going to be right there, and then 2.5, well here's 3, here's 2, 2.5 is in between. Okay, so there's that one. Let's do 5.5, 1.5, so 5.5, that's 1, 2, 3, 4, 5.5. 1.5 is, here's 1, here's and a half. So 5.5, 1.5, right there. And finally, we have this 5.5, negative 2.5. So let's go to 5.5, that's here, and then negative 2, that's negative 2.5, that's down here. So negative 5, positive 5.5, and then negative 2.5, that should be right over here. Okay, so now that we've plotted our 5, it's a little bit more challenging because we had to go in between the boxes by quarters, so 1/4 of a box. Now I'm going to say, let's go ahead and see if we can find which 2 points are going to be 3.5 units apart. So I'm telling you the distance, right? And I'm saying, now that you know the distance, which 2 dots are that far apart from each other. So there's only a few that we could really choose from because we have to see which ones are left and right of each other. So it looks like these 2 dots are left and right of each other. They'll have a matching value. So blue and yellow, blue and yellow. And yes, you can see that they do have a matchy number here, so that's good. This green one can't be used at all, so let's go ahead and just get rid of that. It's not useful because it's not left and right of anything. And this orange and purple, I think we can do something. So orange and purple, do they have any matchy numbers? Yes, they have these 5.5, so we could deal with those too. So I think that's it though, right? You can't use these diagonals, and we can't use these diagonals based on what we know for pre-algebra right now. Later on, yes, with the distance formula or Pythagorean theorem, but for right now, it's going to be either this blue to yellow or this orange to purple. It's one of these two. Okay, so let's check out blue to yellow. So for blue to yellow, what's blue and yellow? Blue and yellow have these matching numbers. So let's see if we can find out the distance between their non-matching numbers here. Okay, so if we take the absolute value of the farther one, one's positive and one's negative, so we have to add their absolute values. So one is going to be negative 1 1/4, the other one is going to be 2 1/4. So the absolute value of negative 1 1/4 is positive 1 1/4, and the absolute value of this 2 1/4 is going to be just 2 1/4. So adding these together, we're going to get 3 2/4 or 3.5. So yeah, I think we did it. So we already found it. So it's going to be this blue dot and yellow dot. So these right here, this distance, this is going to be 3.5 units apart. Okay, doesn't matter what the other one is. Oh wait, no, let's see. The 2 ordered pairs, is the other one also maybe? 3. Let me just check the other one real quick. We said orange and purple. That's orange and purple. I just want to check it real quick. These are the matchy numbers, so let's look at the non-matchies, this and this, just to confirm. They're different signs, so we add their absolute values. So that's going to be 1.5, negative 2.5, so that's 1.5 plus 2.5. That's going to be 3 and a whole, so that's 4. Okay, so they're 4 apart. So these ones over here are not 3.5 units apart. These are actually 4 units apart. All right, cool. So there's 43 different practice problems. What did we kind of cover here? We did distance on a coordinate plane with some fractions and decimals. Okay, we also plotted some points in the beginning. And then before that, what did we do? We compared absolute values of decimals as well as integers as well as fractions, all sorts of rational numbers. We compared them, and that's basically what this video is all about. So hopefully you found this helpful in just getting a little bit better understanding of all these concepts. All right. As always, keep up the great work, and I'll see you in the next one.